So going back to the issues, coding AI agent of GitHub, we have the GitHub ecosystem, and from the developer's point of view, when I write code, let's say I work in a team, we are working on some project, I write code, I write the commit, I push the code to the repo, and I ask my colleague to do the review on my code, and maybe even to fix some issues and find bugs. I worked as a security researcher at one of the big enterprises company in the world, and I remember that working in one of the security products called a WAF, Web Application Firewall, I had to update the code with the new signatures. Each day, new attack vectors has been discovered, and I had to manually test and write the regex and make sure the hacker cannot bypass the new signature and update it and so on. Now, I had to do it manually and tag my colleagues and ask them to review my code, and then we would debate and discuss, and it would take days to accomplish. So, going back to what you said, if I had this AI coding agent in the Copilot workspace, and my code is on GitHub, and so according to what you say, I can just tag the AI agent, the Copilot AI coding agent, and say, instead of tagging Yuval, saying, all right, please review the code, suggest mitigation from this attack on this rule. Would that work? What would be the problem? What the AI could do magically to solve this issue and save time and money and effort?
Absolutely. I mean, it's a very interesting use case. And I think the most important thing with anything is that AI works well within the knowledge space that it's been trained on. So long as there's sufficient knowledge out there for the problem space that you're trying to solve with the model, it's going to do a very good job. If that isn't there, that's where the model is going to fail. And that's where, like, using things like RAG or fine tuning for the specific use cases will improve the outputs of the model. So I'll always come back to, like, you should give everything a shot. And then when like, actually a really good example, which is maybe related to what you say, is, so we have this CodeQL tool, right? So CodeQL lets you, it treats your code like a database, like a relational database, just like you can write an SQL query to look for patterns of data in your database. You can write a query that looks and feels like SQL, it's called QL, and you can, like, look at semantic patterns in your code and tie that to, like, sources and sinks, so, like, where data flows into your application and where data, like, flows out. So
like the inputs and outputs.
Inputs and outputs. So, like, user input flows into a database, right? And then the database is taken and then used to go and, like, write something somewhere. So that whole chaining, so the user input is the source, and, like, the database, and then maybe the subsequent use cases are interesting sinks where you want to check, like, how is that being used, and if someone put something nefarious in here, could that result in, like, information from the database being exposed, or could it, like, result in some other activity that results in, like, a remote code execution or something like that?
Like pen testing.
Essentially, so pen testing would find that problem, and CodeQL is a way of describing that pattern, like in a semantic pattern, so you can look for it.
Cool.
And so interesting use case, right? So it's basically you write it as code, like it's kind of like the SQL query. So you go to Copilot and you go, hey, like, go write this CodeQL query for me, and it turns out that this is other language that is very, very similar to QL. And so the model hallucinates a lot because it generates something that looks so much like CodeQL queries, but it's not. and it's frustratingly not, right? And so what one of my colleagues did was he took all of the documentation for the QL language, all of the reference code that we had, and he used that as part of the prompt that he fed to the model.
Ooh.
And then he said, go write a query that looks for this kind of pattern.
Given the context.
Given the context, and it did an amazing job of generating the query. Like, we were getting like 90 to 95% like accuracy in the code that was generated from, like, garbage that looked beautiful or beautiful garbage, however you want to look at it, to, like, really beautiful stuff that was pretty close to what you would, like, take and tweak a little bit, and then you could go deploy. So context matters, and I think in the same example that you gave, context matters, and whether the context is through, knowledge that's already available, and that's been used to train the model, or it's knowledge that you're giving at the time of doing it. Like, in that role, you probably have been through that exercise many times.
Right.
So if you went back and pulled the history of all the updates you made and the reasons why you made it, those are great annotations of data. Now, if you fed that to the request to Copilot and said, using this information, can you make a recommendation for what my next state should look like? Copilot's probably going to do a much better job at making a suggestion. And I think, so context is, I think, is the secret weapon for getting like high quality outputs today from the models with what we have. Like fine tuning, we've seen, like if you're writing like a JavaScript program today, there's so much JavaScript code out there. Like if you came along and said, and here's like my 2 million lines of JavaScript, I'm sorry, it doesn't, it pales to like 3 billion lines of JavaScript that were used to train the model originally. It's not going to have a big impact. Now, if I'm writing like a low-level device driver for a real-time operating system in C or C++, well, that's unique, right? So there's probably like 20 million lines of that code out there, if that, maybe 10 million. So when you bring in your 1 or 2 million, well, that's like a 20% or 10 or 20% difference in impact that you can make in the model. So you can really start getting some weights moved over to the way that you want to work.